Hello, and welcome to the last session of this 5-part series, The Performance Eye for the SQL Guy. In this session, I'm extending on what we've already covered in the previous 4 sessions over the last 2 features that are being covered that were released with SQL Server 2014 to improve the performance of your SQL Server environment. My name is Warwick Rudd. I'm a Microsoft Certified Master and the Principal Consultant with SQL Masters Consulting. You can read more about me on this slide for yourself. Following on from the previous session, in-memory DW, we are continuing on looking at the remaining 2 features over the course of this series. In this session, we are having a look at the Manage Lock Priority and the Single Partition Online Index Rebuild. So let's get started. Prior to SQL Server 2014, your SQL Server environment can have issues with blocking. Now, blocking is a normal thing. But to work through it, it might look something like this. We issue a select statement against a table. It gets the ability to run that select statement. While that statement's running, we issue a DDL statement. That DDL statement might be a partition switch, or it might be an online index rebuild request. The lock required for the DDL statement isn't social with the select statement. It requires what's called a shared schema lock. So it has to sit and wait until it's able to get that lock to perform what it needs to do. If subsequent select statements are issued against that same table, they sit in the wait queue until they're able to get their lock and continue. So basically what this means is that we have a first in, first out scenario. With the release of SQL Server 2014, this has changed slightly. If we run the same scenario again, we have our select statement, we have our DDL statement. Nothing's really changed. We then run another select statement like we did before. However, they have gone straight up into the grant queue and they are running. That's because they have social locks and they can run together. The DDL statement has to wait for all of those locks to complete for it to then gain its lock and undertake its processes. Now, with the release of 2014, we've got some new functionality that has been given to us. When we issue the DDL statement, some of those options that we've got, we can choose that we want the DDL statement to now sit and wait in the low priority lock queue. We also have the ability to tell it how long we want to wait before we to get a lock before we either kill ourselves or kill the process that is blocking us. To achieve that, we need some elevated permissions. Those elevated permissions are the alter any connection so that we're able to kill that process. With those options, and we'll see more of these in the demo at the end of the next couple of slides, we're able to see how we can go about doing that. It gives us a little bit more granularity, but we need to understand what's in our environment. Now, I've joined it with the Single Partition Online Index Rebuild because prior to now, for you to do a online index rebuild, you had to do the entire table. You couldn't choose an individual partition. If you just wanted to do the partition, then you had to do that offline. So with the inclusion of the Single Partition Online Index Rebuild, it gives us a little bit more granularity because we are now able to choose the specific partition and rebuild it online. The accessibility, it improves our accessibility to the overall environment because while it's just that subset of the table which is being rebuilt, it is a smaller amount of data that is not accessible during that smaller amount of time. The lock priority, and this is where the previous slide comes into it. If we're issuing a index rebuild on a particular partition and we're being blocked by some statements, we can actually choose to kill off that block to improve our performance, get that job done, meet our requirements of staying inside our maintenance window. The availability, because we've got that granularity, we can do it online. We maintain our SLAs and our uptime because we've reduced what we need to have down, the duration for the index rebuild to occur, and our statements can still access the majority of that data. The resource savings. We require less disk space because we require less space in tempdb. We require less space for our transaction logs because we're working on our index rebuilds on a smaller subset of data. We require less CPU because we're working on a smaller subset of data. So overall, our performance is improved greatly by adding these two features together. So let's have a quick look at a demo on these two combined. Now in this demo, to start off, the first thing that we want to do is we want to have a look at what our environments would look like as they are now. So I'm just going to start a transaction that will cause some blocking. So I'm just running this update statement, but not committing it or rolling it back so that it holds some locks. So what we want to have it do now that that update statement has completed, we just want to have a look at the locks that are in our environment. So we can see here that we have an exclusive lock. For the table that we're accessing, that's going to cause some blocking for us. So our normal operation would be we would want to run an online index rebuild against the table that we've currently got a lock occurring. So if we, I need to go into that database. So if we run that and we go back and have a look at what's happening in our environment, we can now see that we've got an exclusive lock and we've got some blocking occurring. So our blocking session 54, which has our exclusive lock, and we're waiting our 52, which is running our alter index, is being blocked. This will just go on for infinitum. So unless you've got a job which is looking for long-running processes, taking longer than what they should, this will just continue on. What we've got now is with that process in play, we can actually run the new DDL statement where we're telling it to wait in the low priority lock queue, wait for a max duration of 1 minute, and then after that minute, if we can't get the lock, to kill ourselves. So let's now run that statement. So that's running away, and this will take about a minute to complete. And if we have a look at our environment again, we can still see that we have the appropriate lock. So we can just see that we've just hit our 1 minute of running and our job has failed because our timeout period exceeded. So now what we want to have a look at doing is, I'm just going to stop that, that locking occurring. So I just want to roll it back. And because one of the things that we spoke about in the presentation was being able to perform the individual partition index rebuilds. So the next thing that we would want to do is have a look at the various partitions and the fragmentation levels of those partitions to determine which partition we need to do an index rebuild of. Now from the results here, we can see that partition 3 has about 58% fragmentation. So it would be a great candidate for us to run an online index rebuild against. So to show how they both can go together, we just need to come back here and start my blocking process again so that we're simulating what would be happening. So that's in play. We come along. Now we can capture the information in an extended event. So if we create a new extended event to capture the information, and we'll just start that extended event. And we come along and we run our same process again, but this time we've changed it so that we're going to actually kill the blockers, not ourselves. So while that's running, we can come along and have a look at our environment session again and just see that we do actually have the blocking that we were waiting on that we have seen in the previous steps in the demo. So in another 40 odd seconds time, hopefully we should see this alter index complete successfully. So we can see from our completed successful statement here that we hit the minute. We then were able to run the index rebuild. So if we just have a quick look at the fragmentation levels, we can now see that partition 3 has gone from 58% fragmented down to about 0.3% fragmented. So it's actually killed off the blocking session, been able to run, and we haven't been impacted other than by a 1-minute delay. Now we can see that by coming back to our extended events, and if we stop our extended event, we then go and open up our extended events, we'll be able to see what actually occurred in our environment. So we can see here that we started our DDL process, and we've been placed into the low priority wait queue, and then exactly 1 minute later we can see that it was killed. We can see the process that was killed and the process that it was killed by. That information is also available inside of the SQL Server error log. So if you're tracing again, if you're monitoring your SQL Server error log, you're able to see that information as well. So that brings us to the end of this 5-part series, where we've covered off the buffer pool extension, the resource governor for I/O. We've had a look at some in-memory technology for both OLTP and for data warehouses, and rounding out with looking at the managed lock priority and how it can work really well with the single partition online index rebuilds. So I'd just like to take this point in time to thank you all for being part of this 5-part series, and I do hope that you have learned some things, and I hope to see you all again soon. Thank you.